Hello, I'm Craig Savage, but you can call me Doc, and I'm starting a new series which I've entitled Real World Analytics, or What Schools Don't Teach You. And I'd like to start off with some frequently asked questions. You may say it's a little odd to have frequently asked questions for a brand new channel. Actually, my channel's not brand new, but this series is. And so these are the questions that I've asked myself about why do I want to have a new series? What do I want to do with this? And I've broken it into some categories. First is, why is there a gap between academia and industry and the people inside it? Second, how can I try to close that gap? So if we first understand why there is a gap, how can it be closed, and what am I going to do about it? Now, the short answer about that is kind of this series, but the cynical amongst you may ask, well, what am I going to get out of it? So first of all, I get to practice with technology and tools that I wouldn't use, such as video recorders, sound recorders, presentations, and I get an opportunity to teach. Unfortunately, I don't currently have a job that pays me to teach, but I still consider myself a teacher at heart, and so this series provides an outlet for me. And so I'd like to start off by talking about why. And there's a quote here that he who knows not that he knows not is a fool. And I've seen that attributed to both Confucius and as a Persian proverb. And the original quote goes on to say that you should shun this person. I view it as show this person, because frequently people don't even understand that there's a question, that there's a greater understanding available. And so they don't even know what questions to ask. They don't even know there is a question. And so the first step, I think, is to get people to see that there actually is something they don't know. And so why am I going to do this? Well, I do think there is a gap between academia and industry, and I wonder why. What causes this gap? And one of the things I see as being processes. In business processes, there's an entire field developed to processes and quality. My wife works in that area. But as students, you don't really learn this. You just kind of do what you do and get on with it. Secondly, I think it's important to look at things end to end. Frequently students, and including myself when I was a student, you're always looking at the next test or the next homework assignment. You don't see the entire path of where this class or this degree is going to take you. And even if that's an outcome you'd like, if perhaps you should change universities, change majors, change classes, etc. And there are certain ways of thinking. In my opinion, something you gain from a formal education isn't just the hard skills, but actually there's a way of thinking. So in mathematical training, you normally talk about things in terms of definition, theorem, proof. So you define your terms, you come up with something that you think is true due to those terms, and then you go on to prove it. And so if you talk to mathematics, they all have this kind of step-by-step definition, theorem, proof mentality. If I look at my business training, then there's a lot of, well, what's my competitive advantage? What can I do better than everyone else? What are the problems I see, and how do I get to the bottom of them, and how do I solve them? So it's just different. And secondly, finally, there's this idea of starting positions that as students, you tend to think about, well, if I do really well, what happens? If I do really well, it may be that I get an A or an S or H1 or different marking or grading systems around the world. But you may think, well, I'm going to be the top of my class. I'm going to do really well. That doesn't work as well in industry for various reasons, which I'll get to in other videos. So now I want to talk about, well, how am I going to do this? A quote here by Barack Obama that the way they can communicate a complex message in a very short space is remarkable. Originally, he was talking about hip-hop music, and I hope the same will apply to technical concepts. So how am I going to do this? Well, I've given some public lectures, both from the Meetup group here in Melbourne, Australia, and at conferences. So in Seoul, South Korea, I went to the Machine Learning and Data Science Community Summit. And I have YouTube videos. You can see those talks on YouTube now. I'm going to do this series, and then I'm also going to make a coffee series of just some informal things. Once again, going back to that way of viewing the world, ways of thinking and starting positions. I'll sit down with a cup of coffee, my webcam, dressed less formally, and just talk about stuff with coffee. Most of my demonstrations are going to be using R, and you may say, but I don't use R, I use blah, 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 blah. So that's the type of kind of specific thinking that I want you to start thinking about avoiding. Because if I do a demonstration with R, it's to prove a concept beyond just the programming. I'm not going to be teaching programming in this series. There are heaps of other resources for you to go out and learn programming. But rather, what's the problem I'm trying to solve? How am I solving it? What are the elements for which I want to use R to solve this problem? And if you can get those elements from anything else, more power to you. Great. So it's not about the details of how I'm solving the problem, but rather what the problem is. What are the key points, the key challenges with that problem that I need to address, and how do I address them with R? If you can address them with something else, fantastic. So what am I doing? And there's a quote here of, "Let me strive every moment of my life to make myself better and better to the best of my ability, that all may profit by it," which is by Doc Savage. Now that's not me, that's the Pulp Fiction hero whose portrait is back there. And so what am I doing? Well, I want to talk about problems versus solutions. Frequently those two get jumbled up, and you may not realize it, but if I give you a question on a test, for instance, you might not look at the problem, you might just start solving it. And talk about things generally versus specifically. Again, going back to I'm going to be doing demonstrations in R. In general, there's a problem to solve, and you're going to write some code or otherwise some procedure to solve that problem. That's the important part, not the fact that it's in R and what those individual lines of code are doing. Metrics versus outcomes. You see this in business and in academia both. What do I mean? Well, if you think back to when you were a student, or if you are a student now, you tend to focus on, well, how am I going to get an A in this class? As a teacher, I don't care what your grade is. I don't care if you get an A. But what I really want to understand is, did you learn the material? And I've seen this go both ways. I've seen students that are lousy at tests, but sitting down in my office hours, they can solve any problem I throw at them. They think about it, and that's more important to me as a teacher. And I've seen things the other way, where I've had students in my class who do really well, and they come back for the next class and they know nothing. And it's sort of about, how did this happen? How is it that you did so well in my last class, and now it seems you haven't retained any of that knowledge? So the metric is doing well or poorly, but again, I'm more concerned about the outcome of, are you understanding the material? And I want to make these relatively short, relatively concise, 5 to 10 minutes, 1 or 2 concepts, and put them out weekly. Thank you for watching. Again, I'm Craig Savage, but you can call me Doc.